Hello, everyone. Thank you for joining us. Good morning or good afternoon, depending on where you are in the U.S. My name is Andrea Hall. I am a Marketing Operations Manager here at Saratech. And I would like to just welcome you to the next installment of our Saratech Enablement series. I will be your host today. And today we have presenting Ilya Nazarenko, and he is with us from Siemens. He is on the Siemens Channel Enablement team. Next slide. Okay, first I just want to tell you a little bit about this customer enablement series that we have. We have this free online training. It's the first and third Thursday of every month at 11 a.m. Pacific Standard Time. And we usually run about 30 to 45 minutes. And our training is always led by subject matter experts, whether within Saratech or one of our partners. And we cover topics, lots of different topics, including PMAP, NX, Solid Edge, Team Center, and much, much more. Our goal for the Saratech Enablement series is really, we're just here to help you get the most out of the software that you already own, or if you don't own it yet, maybe teach you a little bit about it and let you kind of really answer some questions about the software. And we're also here to just share knowledge amongst each other and to build a community of users that'll really help to empower each other to get the most out of our software. And as always, this is an open forum, so we look forward to you participating in the training as it goes. If you have any questions or comments during the presentation, please type them over in the chat box over to the right, right there within GoToWebinar, and I'll kindly interrupt Ilya and let him know about your questions and comments so that way he can answer them right there on the spot. And with that, I will pass the baton over to Ilya. Thank you. And you might be muted, Ilya.
Yeah, okay. Thank you, Andrea.
You're welcome.
Thank you. Good afternoon, everyone. This is a short summary of my experience. Hopefully you can read it for yourself. I'm not going to praise much myself, but I have quite extensive experience in Solid Edge in different areas, Solid Edge simulation, Team Center, and so on. So I've been for 18 years with the company, and specifically 9 years in the channel enablement. So today we're going to talk about Solid Edge simulation. Agenda as follows. So every package, every FAA package needs some good preparation tools. And we are lucky to have Solid Edge simulation tightly integrated with Solid Edge. This allows us to tap into Solid Edge functionality to prep models, regardless where this model came from, whether you design it in Solid Edge or it came from internet source or from competitors. Then we're going to focus on a specific area in the Solid Edge simulation, beam analysis. A lot of people overlook this area because this is a really efficient way to analyze your structure. This specifically aimed at people who build structure, design structures, monocoques, that kind of stuff, supporting structures. And beam analysis allows for quick and efficient way to analyze your assembly without actually, regardless of geometry complexity. And finally, we're going to talk and explore design optimization. This is a tool that is part of Solid Edge simulation and allows you to quickly and efficiently analyze your design and come to a very efficient and the most efficient, I should say, solution while you have a cup of coffee. So system will do it for you. So with that, let's dive into Solid Edge. The first topic we're going to cover is prepping model for analysis. Let's go and open, in this case, I'm going to open ParaSolid, but just to reiterate, Solid Edge offers plenty of options to read foreign geometry into Solid Edge. So besides ParaSolid and common formats like STEP, IGES, we can open NX documents, ACES documents, AutoCAD, DWG-DXF, CATIA, ProEngineer, SolidWorks, Inventor. So pretty much any common and known format out there can be opened inside of Solid Edge. So, and this time I'm going to open a ParaSolid file. Regardless where it came from, Again, you can download this from internet source, or you can get it from a competitive package. So you can see as we open this body, we don't have any features actually. It's a featureless solid body, what we call non-parametric body. The first thing we want to do, since we want to analyze this body, we need to assign material. And it's quite easy to do in Saratech, as you're aware of that probably. You can right-click on material and assign material right away, or you can go in a full material table. So once we assign material with all the coefficients suitable for analysis, we're ready to start analyzing our part. But there's a little caveat. If you know a little bit about analysis, usually model comes in not very prepared for analysis. A lot of small features like tiny sliver faces or geometry might have some problems the way it was built. So Saratech provides excellent tools that allow you to quickly and efficiently get rid of all this extra geometry if you need to. So specifically with Synchronous technology, we can select all this extra geometry and just we want to get rid of and hit delete. We're pretty much done. What about all these radii around? Selection Manager comes to rescue. So if you are familiar with Synchronous technology, you know probably it allows you to pick connected faces, sets, recognize different features, and specifically if we're talking about features that Saratech considers features, even though we don't have feature tree, like all radius of equal value, we can select all that and immediately get rid of that in one single shot. Now, another aspect of analysis is the goal for every analyst and for engineer designer who is using Saratech simulation should be as well to minimize processing time and get geometry as clean as possible before start your study. So if we're talking about this bracket, when you look at it, you might notice that it's symmetrical. And I mean symmetrical not only in terms of geometry, but symmetrical in terms of how we're going to apply the load. If the load is applied to all 8 holes around the bracket and it's held by these 4 holes, we can consider it symmetrical in terms of analysis as well. And this gives us idea that we can analyze only a portion of it, and it's rightfully so. So what we can do here, we can just analyze only a portion of this design. And with Synchronous technology, it's really easy to get rid of extra geometry. As you can see, I could select that region, and with grab and go approach, you can actually switch between close and open profile. If I keep it on close, you can see when I start moving my cursor using steering wheel, it cuts through the part. But if I switch to actually open profile, you can get rid of all the geometry, even though it was open profile. Another area is this little chamfer on each side of the hole. Maybe we don't need that. Again, Selection Manager comes to rescue. By the way, if you didn't know how to invoke Selection Manager, you just hit Shift Spacebar on your keyboard, and it allows you to pick geometry, and immediately you'll be taken to the Selection Manager window. So we can select concentric, and you can see we can select again using quick pick tool. We can select this cone and again use Selection Manager to pick concentric. When we're done, we can hit Shift Spacebar again and get out of that mode and add maybe this small hole also in the equation and get rid of that all in one single shot. I mentioned that sometimes geometry doesn't come very clean, and as a result of surfacing modeling in some other packages maybe, you can see that we have this patched bunch of small faces. That face is not smooth. It's kind of patched up. So we can fix it really easy. Saratech, even though it's a surfacing tool, but Saratech offers this Redefine Surface tool, and it usually works with sheet bodies, but there's a switch that allows you to replace faces on a solid body. If you turn that on, you'll be able to patch up all these small faces with one single smooth face. Okay, and the final step, again, Synchronous technology is very efficient way to deal with your geometry. If we want to get rid of that step, just select that small face and move it up. So now that we prep the model for analysis, we can really start analyzing this design. So simulation, Saratech simulation is tightly integrated with Saratech. So right here, I'm not leaving the environment. It's a one single integrated environment. So right here in Saratech, I can create new study and set up all the parameters for the study. And by the way, to give you some ideas, so we can have designs analyzed in a linear static mode, normal modes, which is frequency analysis. We can do linear buckling, and also we can do steady state heat transfer with a combination of all of the above. When it comes to mesh type, we can have tetrahedral mesh for solid bodies. We can do surface mesh if we're analyzing surfaces, and we can do general bodies or mixed mode. It's a very efficient way to analyze, and I'll show you later how it works. For now, we're going to go with tetrahedral mesh. And by the way, to increase real estate for me to work with, I minimize the toolbar up top. You can do the same if you prefer, or not, you can keep it up. And then Saratech simulation is really easy to use tool. You progress from left to right, and you logically progress from defining loads, defining boundary conditions, constraints, and then defining mesh, and finally solve. We can start with defining force. And since we're analyzing only quarter of the real geometry, we want to give it quarter of real load. So if we consider this whole bracket to be under 1,000 newtons of force, so we can instead of 1,000 we can go with 250 newtons. Another way, Saratech simulation is very flexible when it comes to user interface. So instead of relying all the time on this toolbar, I can open sidebar and access it this way. I prefer this way because it gives me more real estate to work with. So you can do pretty much the same thing here. We applied already load. We can see that load. And as far as constraints, you can apply different fixed constraints, pin constraints, sliding along surface, cylindrical, and user-defined. So in this case, we're going to fix this bracket against this threaded hole. And because we're analyzing only quarter of our design, we need to apply constraints such as a sliding along surface, because this will let the system know that this quarter of our bracket will behave and will be analyzed as a part of the rest of the bracket. This face and this face defined this way will give system idea that this is only part of the whole design. And then finally, we can do mesh, and conveniently Saratech simulation offers you a way to mesh and solve in one single operation. If it's a simple model like this, obviously it makes sense. If it's more complex, you can first define mesh and then go and solve it. So immediately after system process the study, it brings back results into post-processing window. And it's a very important part of every FEA package. And Saratech simulation really shines here. So first of all, you can take a look at the results in many different ways. So right now we're looking at smooth contour, which means the color mapping is progressing smoothly throughout the mesh. We can switch to banded contour when it's more pronounced. Then finally we can take a look at element contour, when every element of a mesh assigns specific solid color. And finally, my favorite, ISO contour. This gives you a really good idea. I can switch even dynamic contour and go through results dynamically. So I can see where is my highest stress. As you can see, immediately I can see the distribution of the same level of stress, or I can go where and see where my lowest stress is. This is really great tool to quickly look at the results. Also, we can probe our design. So you can pretty much select any node and include even displacement. If you turn on this option, you'll be able to get results for displacements, and all this information can be holding shift. You can select all this, copy and paste, let's say, an Excel spreadsheet. It's a very good way to preserve information for future consumption. You can animate the results, because this gives you a good idea how stress actually affecting your model and how it will behave under stress. You can adjust if you, obviously it's like exaggerated weight percentage right now set to 10. You can go to actual, and this gives you actual deformation. You can save it as a movie if you want. Really user-friendly, you're really a powerful tool. So let's go back. Next step, I want to show you how you would use more advanced technique to get at the more accurate results. A lot of analysts usually like to fine-tune their mesh, and that can be accomplished in solid edge simulation as well. So right here, if I go under mesh, you'll find these extra options: edge size, surface size, body size. This allows users to fine-tune mesh. Let's say if I go with edge size, I can pick, I can pretty much define how many elements I want along this particular edge. So I can pick all these edges that I want to apply this particular parameter on, and then just define how many edges I want to have along those. So 24, you can see how it gives me nice dynamic preview if I accept it. So what happens now, if I go mesh and solve, it will take into account that setting first, and then it will go with the regular slider for the whole model. And if you take a look at the results, you can see now how nicely solid edge simulation takes care of progressing from coarser mesh to finer mesh around the stress concentrator. So you can see for yourself how nice of a job it's doing automatically. Okay, so we covered some basics, how it works, how you set up your study, how you get results and analyze them. So let's go and take a look at that next topic that I promised you to cover is a specific, okay, let's close this guy, and open assembly. I'm going to be working on engine hoist assembly, and we're going to analyze this. Obviously, it's very important to analyze this structure because company that is making this kind of equipment is liable if anything happens. So it's very important to make sure that the product is reliable. Liability is a big issue out there. So with solid edge, as you know, you can quickly isolate, let's say, specific components on the screen that we need to analyze, in this case, member of this frame. And if we go into environment, which is a frame environment, simulation is present there as well. And when I create new study, it allows me to actually do beam analysis. Instead of dealing with geometry, you will see how it happens. When I create a new study, I can select all the members of this frame, and system will give me this nice linear representation of every member, regardless of geometry complexity. So now I can apply force, and by the way, force can be applied in this case to the whole curve, distributed, or to a specific node, to the point. This is 2-ton hoist, so we're going to apply 20,000 newtons. And as far as fixing it and analyzing against, again, conveniently I can switch to node. The nice thing about interface, you don't have to precisely select the point. If you close enough, you can see I just get close enough and click, it will automatically select points for you. So now we fix all those caster locations, and all we have to do is just mesh and solve. And this processing time would be extremely fast because we're dealing with a beam. That's really big advantage of using beam analysis for structures like that. Again, regardless of geometry complexity, it will give you really accurate results and fast. Let's animate and see how it will behave under this stress. Obviously, the way we expect it, it's going to be pulling down. And using our probe, we can quickly and efficiently get information about specific points. So if I take a look at these points, you can see that stress here is about 80 megapascals, which is more than 4 times less than yield stress. So we have room to negotiate, so to say. So we can, obviously these members are over-designed. So this is another side of the medal when you don't want to be liable if product fails, but at the same time, you should be able to save money for the company by not over-designing your product. And this is great way to save money because we can go and reduce the strength of this component. Maybe we can go to smaller members here in the back. And because it's one single integrated environment, it's quite easy to do here. Again, all I have to do is just solve. It will go and solve. It knows all about mesh. It knows all about boundary conditions and the loads that we set up. And if we probe now, you can see just even by color, you can tell we're now at somewhere at close to 200 megapascals, which is about 2 times lower than yield stress, and we are good there. Another advantage that Saratech simulation brings to the table is ability to perform multiple analysis on the same model or assembly. So again, using Saratech functionality, I can switch display configuration to leveler. This is another important part of the design because this is the part where engine is going to be hoisted. So we want to make sure that we can withstand that load 2 tons. Another aspect of Saratech simulation is, remember, we aim at efficiency. We want to make sure that we spend only as much resources and time as necessary. So under Saratech simulation, we have ability to extract mid-surface from a sheet metal parts right on assembly level. We don't have to go into single component, every one of them. We can do it right here on assembly level. And then we can do the same thing on the other side as well. Right. So now if we isolate, let's say I want to hide this component that we don't want to see here, and you can see that system extracted mid surfaces. They're available right here on assembly level. Before I start setting up my study, I would like to show you how this mechanism works. So if we take a peek inside, you can see that we have this threaded rod that goes through adjustment bracket. If that rod gets too much deflection, the whole mechanism is not going to work properly. So our goal here is to, while preserving the strength of the structure, we want to minimize the travel deflection for this mechanism. So that's what we aim at here. So, and then same idea. Again, I can open sidebar and start creating simulation here. New study. This time I'm going to use mixed mode because I have some sheet bodies as well as regular models. And then I just select all those components that are relevant for our study. These 4 components, obviously the beam, 2 side brackets, and the supporting piece. So let's go and apply some loads. Before actually, I want to show you that those mid surfaces we extracted on assembly level. Saratech simulation is smart enough to know the material assigned to them. It knows about thickness. So all this is done automatically for you. You don't have to go and manually assign thickness and make sure material is assigned. It all happens automatically. So let's go apply loads. Obviously, we're going to load with the same level of that we used for the whole hoist. And conveniently, you can apply load to face, edge, point, and feature. And we're going to use that in a little while. But for now, I'm going to pick edges. Let's switch the direction. And again, as I mentioned, we're going to assign load of 20,000 newtons. And as far as constraint, we're going to analyze against these little 4 faces. Conveniently, I can use feature. And when I select that geometry with quick pick, I'm able to actually cycle through and pick those 4 small holes. Probably they're cutouts. Think about it. You have ability to dive into component and pick feature and assign constraint to that geometry. Now, because it's assembly, we need to tell the system how these components interact with each other. Connectors come to rescue here. And when we go with connectors, you can have different type of connectors. We can do manual connection, meaning that you pick manual component that you want to make sure Saratech simulation knows about how they interact with each other. You can do automatic connection. That's what we're going to do. You can do bolt connection. And we can do bolt connection. It allows you to avoid modeling or having actually bolts, real bolts, as a part of your study. It speeds up your study, and you don't have to have bolts modeled. You can mimic even through bolt connection, and you can even preset pre-stress with a force. And edge connection, when you are able to connect edge to a face, it's very, very important when you're dealing with the sheet bodies, when you analyze sheet bodies. So let's go with automatic connectors. Because we extracted mid-surface, and obviously there is a gap, we want to define search distance slightly larger, like 5 millimeters, and then select all parts in this study. And when we accept that, conveniently Saratech simulation gives us a list of all the connectors that it finds based on search tolerance. And you can walk through and you can see system conveniently highlights and shows you graphically which one is which. If you don't like some of them, you can right click and delete. But in this case, I'm going to accept and create all those connectors for these components. And what's left to do pretty much? Yeah, let's turn off these loads and connectors. We don't need to see that graphics. And then we can just do mesh and solve. And the system will go and solve this assembly for us, and you'll see that the processing time is really fast because part of this assembly is sheet bodies, not solid bodies. We can animate this, and you can see, obviously I want to go and switch to visible results. Excuse me. So let's switch to actual results. And while I'm at it, Saratech offers you in post-processing window, it offers you different display options where you can turn on plate thickness. So as I mentioned earlier, we're interested in displacement. So let's go with displacement and animate this in actual mode. You can see even in actual mode, the displacement is about 8 millimeters. That's probably too much for this kind of mechanism. As I mentioned, this threaded rod not going to work properly with adjustment bracket. So what we need to do, we need to lower the displacement and stress accordingly. I could just apply different configuration, and as a matter of fact, let's do that. I'm going to select, even though I'm in assembly, I can select face from that part that I want to adjust, and conveniently I can adjust it from assembly level. With Syncast technology, you can just type in new value because that dimension was part of that design part, and I can even adjust the thickness. Let's say instead of 2 millimeters, let's go with 3 millimeters. So this is how quickly, because it's a single integrated environment, Saratech simulation is part of actually Saratech. This is how easy it is to change geometry and reanalyze, rerun analysis. And you can do it over and over again, but instead I'm going to show you more efficient way how to do that. If you have at least one study in your study navigator, you can right click on it and say, let's do optimization. So you go through easy to understand and set up wizard. And our objective would be displacement in this case. We have right now about 8 millimeters of displacement. By the way, you can set up minimum, maximum, or target value. In this case, I'm interested in target. So I want to make sure it's 1 millimeters or lower. And the next step, we're going to set limits. So what we're going to control it with. So we're going to take a look at stress because we want to avoid any liability issues. We want to make sure that stress is below certain level, let's say 190 megapascals. And finally, let's move on to next step. What are we going to be adjusting while we're arriving at optimum solution? We're going to be adjusting variables that control geometry. And we can adjust variables from the top assembly, or conveniently we can dive into component. I'm going to select this member and pick up pick two variables from here, thickness of the wall and overall length, and add to our wizard window. And by the way, the range that was defined in the variables, it comes through also. So, and finally, you can define how many iterations you want to go through. This is demonstration, so if you really do analysis, you might go with higher number, but for now, 4 is okay. And I say optimize. So it's, as I mentioned, it's easy to understand, easy to follow wizard. Once you set it up, you can go grab a cup of coffee, and if it happens so that you're in front of your monitor, you'll see how it goes and changes the thickness of the member and overall length of the member, and it's trying to arrive at optimum solution. So when you come back with that cup of coffee, Saratech simulation will present you with the final result. And to make it actually recordable and efficient in terms of reuse later, you can take a look at summary of these iterations. And we take advantage of Microsoft Office in this instance. So Saratech takes all these results and pops into Excel spreadsheet. And obviously the last iteration, this is the one we are looking at. You can see that it went through some iterations that some of them were ridiculous, but we arrived at desired value. We have the total translation slightly over millimeter, and it gives us 5.249 thickness of the wall for that member and 683 and change for the overall length. So obviously stock is not available in these decimals. So we need to adjust to, let's say, 5 millimeters and maybe 650 for the length to make sure. But you can save the spreadsheet for future references or share it with anybody and so on. So again, because it's a one single integrated environment, we're going to select parameters right from assembly, type in new values, and change even wall thickness, exactly 5 millimeters for the member. And rerun analysis. It's easier just solve, because remember, it knows all about boundary conditions, loads, mesh options, and whatnot. And if we take a look at displacement, so let's take a look at actual displacement again. It's a 0.942, so it's lower than 1 millimeters. Let's animate it and see how it works. So you can see it barely moves, so we arrived at our optimum solution. And if you want to have it recorded or have some reference for later to show to your boss or share with an organization or customer, you can create a report. With one single button click, you'll be able to create a report and capture it in HTML-based format or Microsoft Word format. So when you hit create report, it captures all the information, starting with material properties, all the loads, and you have a nice table of contents. Let's say you can take a look at loads, or you can take a look at the results. Let's say total translation, that's what we arrived at. And this is really a powerful way to capture or document your design, your study. And you'll be able to share this information, again, archive it, share with anybody within an organization or outside. So coming back to summarizing what we just went through. First of all, I showed you how Saratech simulation, being tightly integrated with Saratech, can take advantage of Saratech tools, and particular synchronous technology, to prepare data for analysis, get rid of any unwanted sliver faces, small faces, and fix geometry if required. Simulation is fully integrated, as I mentioned, so which means it's a one single environment, one click away to go and change your geometry. It provides a multitude of analysis types, so you can perform stress analysis, you can perform beam analysis, you can do model analysis, and you can do heat transfer analysis, steady state heat transfer analysis. And finally, built-in optimization is a great way to arrive at optimum solution while you have a cup of coffee. That's all I had for today. Thank you for your time. If you have any questions, please let Andrea and me know.
Thank you, Ilya. Great job. Yes, thank you for attending. I wanted to let everybody know this online training today and all of our webinars and other enablement sessions are always posted on our YouTube channel. And if you just search for Saratech Inc. in YouTube or go to this link that you see here, you'll find all of our sessions on there. They're all about 30 to 45 minutes long. And I will be emailing everyone with the replay link. Please reach out to us if you have any questions or comments or suggestions for future webinars. We would really, really appreciate that. And if you'll just stay on for maybe another 20 seconds or so after we log off, a little survey will pop up, and we would really appreciate it if you would just let us know how we did today. And again, you'll have a chance to leave any comments there as well. And thank you all very much, and I hope you have a wonderful day.